So guys, let's look at this question too and see if it's a variable separable differential equation. The question is where to solve this differential equation. So the first thing we'll do, if I'm given this question now to solve, the first thing I will try to do is I will try to check, is it a variable separable differential equation? And to know if it's a variable separable differential equation, it means the expression of x should be separated completely from the expression of y. That is, we should be able to write it in the form the y with respect to the x equals f of x separate, g of y separate. So let's see. In this case now, if I were you, I'll try to break this exponential using the law of indices, that the y to x equals exponential x dot exponential minus y. Because the rule states that when the same base multiply, their power adds. So we can easily separate that. Plus x squared exponential minus y. From this now, we have been able to observe that exponential minus y is a common expression from both to these two sides of the expression. So I can easily say the y with respect to the x equals exponential minus y all into exponential x plus x squared. What do we observe? Beautiful. All we can see is that exponential y, all expression of y are standing separately, and all the expression of x now separate too. Which means this is an example of a differential equation under variable separable. By that, the next thing I will do is to cross multiply so that the x will be with x, function of x, and function of y will be with the y. So by that, I can say the y is equals to exponential minus y all into exponential x plus x squared dx by cross multiplying. What this tells us is that these are expression of x beside dx, but this one is expression of y. We need to bring in that a, and the only way is to divide both sides by exponential minus y, just like we have done in the first example. So by that, we say exponential minus, we use it to divide both sides, exponential minus y. So this gets divided here. And don't forget, there's a coefficient of 1 here. Ladies and gentlemen, I want to quickly show you something. If you have 1 divided by exponential minus 1, this is the same as saying 1 divided by exponential minus 1 is the same as 1 exponential minus y, sorry. I mean to say, is the same as 1 over exponential y. And by the time this change to multiplication, you can have it as 1 times exponential y over 1, which is exponential y. In that light, I can easily rewrite this as exponential y dy equals exponential x plus x squared dx. Don't forget, the other time when we are solving the first question, I said whenever you have been able to separate the variable x and the variable y completely, whereby you have function of x with the x, function of y with the y, the best thing to do next is to integrate both sides of the equation. So we can say integral of exponential y dy equals integral of exponential x plus x squared all in brackets dx. And the integration of exponential y is exponential y, where you can also add this as exponential x plus, if you integrate x squared, that would be x raised to power 3 divided by 3 plus c. I would have loved to write this as exponential, but because there's a cubic expression here, so it's better to leave it as c. So, ladies and gentlemen, if I want to, I may want to remove this exponential, but it's better to leave your result like this. So Or I will say, you want to bring this log, you want to bring it, you want to bring this y, you want to bring it down. So what you do is you apply log to both sides, log to base e to both sides of the equation, and this becomes log exponential y base e equals log exponential x plus x cubed over 3 plus c, all of this to base e. And from here you have that y is equals to log exponential x plus x cubed over 3 plus c base e. Now the question is, this is the solution, but the question is, how do you know that this is a solution? Number one, let's listen please. The differential equation you have solved is a first order differential equation. If your differential equation is a first order differential equation, the number of constants you are going to have in your solution will be just one constant. That's the first thing. And second thing is, like I told you, the solution to any differential equation is also an equation. I hope you're getting it now. So this is an equation whereby it contains just one constant. That constant is telling you that the differential equation that gives this result is of order 1. So ladies and gentlemen, I will be dropping more questions which you'll be able to practice under variable separable in the description below. Please kindly check, and we would also like you to like, subscribe, and help us share this video. We hope this will benefit you in one or two ways. Thanks for watching. See you in the next class.